Hi everyone, the chapter which we are doing today is chemical equations and reactions, and here is a quick revision of the entire chapter. Let's begin. What is a chemical reaction? Whenever we say there is a chemical change taking place, we say there is a chemical reaction. What is a chemical change? In which a new substance is formed which is completely different in properties from the original substance. So we can say the properties of original substance is totally different from the properties of new substance. And then we say there is a chemical change, that is a chemical reaction taking place. What are the few examples? Rusting of iron, digestion of food, respiration, etc. etc. All those substances which undergo a change or which are taking part in a chemical reaction, they are called reactants. And the new substances which are formed in a chemical reaction, they are called products. For example, if I burn magnesium in air, it forms magnesium oxide. So we can say magnesium and oxygen, they are reactants because they are taking part in a chemical reaction and undergoing a change, and the final substance, which is magnesium oxide, is a product. This was a word equation. There's another shorter way for representing these word equations, which is when we use chemical formula. For this, you need to learn all the symbols and valencies. So as you can see, I have represented magnesium with Mg, oxygen with O2, O2 because it's a gas and it's a diatomic molecule, magnesium oxide by MgO. So this was one shorter way of representing chemical equation, in which I used chemical formula. As you can see here, on the left hand side of the equation, Mg has one atom and right hand side magnesium has one atom. But on left hand side, while oxygen has two atoms, on right hand side oxygen has one atom. As a result, if number of atoms of each element is not same on both the sides of the equation, we say that such chemical equation is a skeletal chemical equation. What is a balanced chemical equation? Whenever there is a skeletal chemical equation, there is a need to balance those chemical equations. Why? Because of law of conservation of mass. It states that mass can neither be created nor destroyed in a chemical reaction. So the total mass which is present in the reactants has to be equal to the total mass which is present in the products. And for this, the number of atoms of each element should be same on both the sides of the equation. So we need to balance a skeletal chemical equation. Like you can see in the example given here, on left hand side, zinc has one atom and right hand side, zinc has one atom. Left hand side, hydrogen has two and right hand side also, hydrogen has two. If we talk about sulfur as well as oxygen, they are balanced too. So as the number of atoms of each element is same on both the sides, so it is a balanced chemical equation. Now let's see how to balance the chemical equation. As you can see one skeletal equation on the screen, which says hydrogen gas plus oxygen gas makes up water. As you can see on the left hand side, hydrogen has two atoms and oxygen also has two atoms. And on right hand side, hydrogen has two but oxygen has one. So we need to balance oxygen first. On right hand side, I need to add a 2, and this 2 will make what? This 2 will make hydrogen atoms to 4 and oxygen atoms to 2. So now oxygen is balanced, but hydrogen is not. Now on left hand side, I need to add a 2 in front of hydrogen. This will make hydrogen to 4 now. And now my equation is absolutely balanced. Hydrogen atoms are also same on both the sides, and even the number of oxygen atoms are same on both the sides. So this is called a balanced chemical equation. And the method which we use to balance chemical equations is called a hidden trial method. It's a very important concept from examination point of view also. In this video, we'll be studying the following types of reactions. First, a combination reaction. Second, decomposition reaction and its types. Third, displacement reaction. Fourth, double displacement reaction. Fifth, reduction and oxidation reactions, and we'll also study about redox reactions. Let's study about combination reaction first. Those reactions in which two or more reactants combine to form one product. They are called combination reactions. They are generally represented as A plus B forms AB. So two or more reactants are forming one single product. Let's look at few examples. When magnesium is burnt in air, that is oxygen, it will combine to form magnesium oxide. Let's see one more example. If calcium oxide is reacting with water, it is producing calcium hydroxide. So in these examples, we can see two or more reactants are forming a single product. These are called combination reactions. Let's move to decomposition reaction. These reactions are totally opposite of combination reactions. In these reactions, there's one compound which is decomposing to form two or more compounds or elements. So it is represented as reverse of combination reaction. Here, AB is split into two or more elements or compounds, that is A plus B. To carry out decomposition, there is certain energy required. That can be heat, electricity, or light or sunlight. If heat is used to decompose a compound, that is called thermal decomposition. As you can see one example here, lead nitrate. If lead nitrate is decomposed on heating, it is forming lead oxide, nitrogen dioxide, and oxygen gas. Second, if electricity is used to decompose a compound or a molecule, that is called electrolytic decomposition. As you can see, water here is decomposed into gases which are hydrogen and oxygen. If decomposition is done with the help of sunlight or light energy, that is called photolysis or photodecomposition reaction. For example, if AgCl, that is silver chloride, is kept in sunlight, it decomposes to form silver and chlorine gas. Also, not to forget, decomposition reactions are using heat or some form of energy, so they are also called endothermic reactions. And combination reactions, since a lot of heat is involved in those reactions, they are called exothermic reactions. Let's talk about displacement reaction now. The chemical reactions in which a more reactive element displaces the less reactive element from its salt solution are known as displacement reactions. They are generally written as A plus BC is AC plus B. Here what happened? A was more reactive than B, and that is why it displaced B from its salt solution and took its place. Let's see one example. If I keep some iron nails in a copper sulfate solution, iron, being more reactive than copper, will displace it from its solution, will take its place. And we'll get ferrous sulfate, that's FeSO4, and copper. Iron nail will become brownish in color due to the coating of copper on it. And blue color of copper sulfate solution will fade to light green color of ferrous sulfate or iron sulfate solution. So here, iron, being more reactive, has displaced copper from copper sulfate solution. Let's talk about double displacement reaction, one of the most important ones from examination point of view. So those reactions in which ions are exchanged between two reactants, which results in forming two new compounds, they are called double displacement reaction. Let's look at one example. When a solution of barium chloride, it reacts with a solution of sodium sulfate. I repeat, there's a solution, there are two solutions. One is barium chloride, one is sodium sulfate. So what will happen? The ions will exchange between the reactants, and the products formed would be barium sulfate and sodium chloride. Here barium sulfate would be an insoluble substance which is also called a precipitate. It's a white precipitate here. So double displacement reactions in which there is a precipitate or an insoluble substance is formed, it is also known as precipitation reaction. Even neutralization reactions are examples of double displacement reaction. As you can see here, I've taken the example of a base and an acid. Base is sodium hydroxide and acid is hydrochloric acid. And the products formed are sodium chloride, that is salt, and water. Here also ions are exchanged between reactants. This is a neutralization reaction as well as a double displacement reaction. Let's talk about oxidation and reduction reactions. It's a very simple but very important one. The addition of oxygen or removal of hydrogen from a compound, it's known as oxidation. And addition of hydrogen or removal of oxygen from a compound, it's called reduction. Two more important terms here are oxidizing agent and reducing agent. A substance which is oxidizing another substance and itself is getting reduced, it is called oxidizing agent. And a substance which reduces other substance but self is getting oxidized, that is called reducing agent. Let's look at an example here. In this example, copper oxide it's losing its oxygen and it is being reduced, and hydrogen is gaining oxygen, so it is being oxidized. And those reactions in which one reactant gets oxidized while the other is getting reduced, these are known as oxidation reduction reactions or redox reactions. Here, copper oxide is self getting reduced and is helping hydrogen get oxidized. So that is why it is an oxidizing agent. And hydrogen is getting oxidized, but because of hydrogen, CuO is getting reduced. So H2 is a reducing agent. Two practical applications for oxidation reaction are first corrosion. It is a gradual deterioration of any metal. Because of moisture, air, acid or any chemical in the surrounding environment, this is known as corrosion. Corrosion causes a lot of damage to a lot of metals, car bodies, bridges, iron railings, ships, etc. and so much money is spent to replace that iron. Few examples here are of first rusting. As you can see, iron, due to contact with air and moisture, it is leading to the formation of ferric oxide. It is also called here hydrated ferric oxide or rust. Second example is corrosion of copper. Cu, because of contact with air, like what all you have in air? You have CO2, you have O2, you have moisture, etc. So what is being formed? There's a mixture of two substances, two compounds. One is CuCO3, that is copper carbonate. Second is CuOH2, that is copper hydroxide. The mixture of two is also known by the name of basic copper carbonate or copper 2 carbonate hydroxide. Third example is corrosion of silver. Silver reacts with hydrogen sulfide from air, and as a result there's a black coating of silver sulfide on it which is formed. Let's look at the last part or the last practical application of oxidation, that is called rancidity. Whenever the foods containing fats and oil, they are kept in air for a long period of time, the food gets oxidized and it gives foul smell and bad taste to the food. It can cause stomach infection on consumption. So what are the ways to prevent rancidity? You can use airtight containers. You can package the food with nitrogen. It will prevent food items from oxidizing. Why? Because nitrogen is an inert gas. It does not react much. So it will prevent the contact of food items with the oxygen present in the air. Refrigeration is a very important tool which you can use to prevent rancidity. In fact, if you add antioxidants or preservatives, that will also save your food from oxidation. And here we wind up our chapter. Hope you enjoyed the revision. Thank you. Do subscribe to our channel for more such videos. Keep watching, keep learning.